All right, let's get started. Thanks so much for joining us today. Today we're going to be talking about how HTML5 video players work and what to know and understand if you decide to build or even to buy your own. So my name is Erica. I'm head of partnerships at StreamYard, and I'm here with one of our founders and COO, Nikolai Radionov. To give you a little bit of background about who we are, StreamYard is a leader in peer accelerated delivery technology for large-scale OTT portals. And so our solutions are designed to overcome some of the price and scaling issues associated with traditional CDNs and kind of to offer a more robust video delivery architecture. So why HTML5? Over the past couple of years, we've been really exploring the inner workings of HTML5 media engines via our different integrations into open source and proprietary video players with our customers. And this has allowed us to gain really a lot of experience in this area. And today we actually offer a service to help broadcasters make the transition from Flash to an HTML5 workflow, do workshops, benchmarks, and kind of support in the development of a new video player for some tier 1 broadcasters. So this is obviously a subject that we like to talk about, and if you're interested in doing a sort of follow-up after the actual conference, don't hesitate to come see us. So today we're going to start by talking about what is actually inside an HTML5 player, the main layers, how they work, and how they interact. Then we're going to have a look at what we should be looking for feature-wise according to your different business and technology goals when you're in the market for buying or building an HTML5 player. And then we'll finish up with a short benchmark of some of the open source solutions that are out there on the market today, kind of assessing the pros and cons and just taking a look at what we have out there on the market today. Finally, just to finish up, we'll probably take a couple minutes to talk about what is actually involved in building an HTML5 player and if it's the right fit for your company and for your workflow. So what's inside an HTML5 player and how is it built? I think we're all probably familiar with the solutions that are on the screen right now. What is everyone using today in terms of video player? How many people are using JW? JW, okay. Any Brightcove? One sort of Brightcove?
We're using Video.js.
Okay,
Yeah.
Video.js, of course. What else are you using? Nothing else? Video.js and JW player? Okay, so we're all quite familiar with these solutions, but what we thought was important to understand today was actually what was going on behind the scenes and how these players actually work, how one of the off-the-shelf players is actually built and what goes on really behind the scenes. So when we really thought about it, we came to a pretty simple conclusion that an HTML5 player is not so different than your favorite burger. And so thank you to whoever scheduled this, because if we had done this before lunch, I think we would have lost you all. But the analogy actually works really well because HTML5 has offered a much more flexible framework, and we're getting further and further away from kind of the black box Flash type technologies and into a world where if you can imagine it, you can most likely build it. So what exactly is involved in an HTML5 player? The most upper part of the player, the high-level part of your player is the user-facing part, and that's what we're going to call our user interface. And that's made up of the skin of your player, which is the design of the player itself. To that, we can add on any sort of business logic features, such as payment, authentication, any sort of ads. And then finally, in that layer, we have any sort of custom user interface features that go around the player, such as like playlists and social sharing, et cetera. We then move on to the quote-unquote meat of the video player, your media engine. There we go. So this is going to handle all of your playback logic, such as your manifest parsing, retrieval of video segments, and all of your adaptive bitrate rules. So it's no accident that we chose the meat of the burger for this part, because it's probably the most important part of your player. And it's important not to ignore this part, because if your media engine is not very good, your entire player is going to be subpar. And you can put whatever on top of it to mask that, but you're not going to be able to really mask that. So it's often a neglected part of the video player, but it's one of the most important. And then finally, on the bottom layer, we have everything that takes care of decrypting, decoding, and rendering the segments on the screen. So we have the DRM manager, the content decryption module that's actually baked into the browser, and then the decoder and the render. So let's take a look at those in a little bit more detail. First, we have the user interface, obviously, which is everything that you can customize with your brand's identity. First, we have the skin, which can include, obviously, a control bar, buttons, animations, any sort of icons, et cetera. And then next, we have all of our UI logic, the features defining the interaction with the video player on top of just simply playback. And so we have, these can include playlist bar, thumbnails, channel selection, social sharing, et cetera. And the nice thing about a lot of these, if you're using a solution like Video.js, for example, a lot of these exist already as plugins that you can add to your UI core. And so if you take a look at the example of Video.js, they have an enormous list of all of these different plugins that you can have on your player. And so we took the example of the Eurosport player, which actually has something very cool. A kind of switch back to live where you can actually watch the live stream at the same time as you're doing a catch-up and kind of very easily switch between the two of them. And what's nice in HTML5, which is a kind of a big difference with Flash, this is something very easy to do with just a few lines of code and your media engine. And so you can have several instances of the player and have two different videos actually within the same player very, very easily. So the third component of the user interface is what we like to call your business logic. And this includes anything like, as I said, authentication, payment, any type of ad service that you might be using. In addition to these three, perhaps the most important one on this is actually what we call your configuration logic. Because it's going to be very important for you to actually be able to detect your user's device and configure the user experience accordingly. And what's nice is with HTML5, you're generally going to be able to develop all of your UI features very simply in CSS and in JavaScript, and then be able to reuse them across all of your devices to have like a seamless user experience, even if what you have underneath, your media engine underneath, might differ from platform to platform. So that's one of the beauties of kind of being able to separate your actual playback logic and your UI logic in HTML5. So here we give an example of what this actually looks like with a kind of UI workflow. Everything above the horizontal line there in blue is what the user actually sees on the screen, and then everything below that is what is going on behind the scenes. So we have an authentication step that allows us to display the player on the screen. We then have channels and highlights feature that allows us to see the different channels and highlights. And then we also can launch a pre-roll ad, a customizable pre-roll ad, by using the user database and an ad exchange to get something that's customizable to your user. Just a simple example of what that can actually look like. So to sum that up, the user interface is really easily customizable. There are a lot of features that are already available as plugins that you can kind of use out of the box or use as inspiration to build your own. You can also very easily create a unified experience, user experience, across browsers and platforms, even if the media engine behind it may vary from device to device. So you can reuse a lot of what you do for desktop, for example. And that's really the beauty of being able to keep your UI separate from your core streaming engine. Moving on to the media engine. It's actually quite recently that the media engine has actually become a separate component from the larger player. And that's because HTTP streaming has introduced a lot of complexity with dealing with multi-bitrate streams. We need something that's going to be able to estimate and to accurately tell us what bitrate we should be streaming on, and something to control and handle all of that new complexity. So with HTTP streaming, everything starts with a manifest. And the manifest is going to contain all of your the metadata needed to understand what the media server has to offer. So we're going to see how many qualities we have, audio and video, any sort of different languages, subtitles, et cetera. It's basically a sort of map of your content. And as the player is going to be the one that decides which quality it needs to get, it needs to know where exactly to ask for it. So that manifest is basically that map that contains the different data to know where to actually get these different options. We then have the downloader that downloads the manifest. It downloads any DRM keys that you're using, and it will also download the actual media segments. The downloader plays an important role of handling all of the errors and retries, and it also collects a lot of statistics on the available bandwidth that are then used afterwards by the ABR controller, which we'll talk about in a minute. And this is actually where we add StreamRoots integration into the player. We basically replace the downloader that the player has in it with our own downloader that allows us to get content from multiple sources, from both the peer network and from the CDN, which is kind of cool. We then have the manifest parser, which gets all of the manifest data in the form of an XML, and then follows the different specs to extract the right information. So the parser uses this to interprets this and gets the data in order to build its own vision of the stream and understands how to get the different tracks. At this point, you'll probably also need a transmuxer, especially if you're doing HLS, as all of the different platforms have different restrictions in terms of packaging and codecs. Next comes the streaming engine, which is the most complex part, and that handles retries and ties everything together. It pushes the different media segments into the decoder and handles all of the quality switching and the playback specificities. For example, if ever you have a discontinuity between timestamps of two different segments, the player doesn't always know what to do with that, and it's the streaming engine that can kind of seek ahead for a couple milliseconds to get that right and to not have any sort of playback stalls. So it handles all of that stuff, and it also listens to the ABR controller to see which quality we should be streaming on. So the last part is the quality metrics and the ABR manager. So here what we have to do is kind of aggregate all of the different metrics that the downloader has, such as the chunk size, the time it takes to download a segment, the number of drop frames, et cetera. And then it's going to apply intelligent rules to that to understand exactly what bitrate we should be streaming on. So this is, and then it tells the streaming engine if it should be changing qualities or not. So this is obviously a very important part of the video player. It's often overlooked, especially if you're just looking to do kind of a light touch development on it on your UI. But it's a very important part if you really want to have something that's completely adapted to your use case, especially for everything around QoS. So to sum up, obviously it's important to understand what's going on behind the scenes, especially if you want to build. You'll probably have to have several media engines to cover your entire audience because they're format specific. So you'll have an HLS engine, a dash engine, you have a flash fallback probably. And this is also because the decoder layer, which we're going to see right now, is linked to the user's platform and to your browser and to your operating system. So going into the decoder, which is handles the most low-level playback logic. We don't want to get into tons of detail here. But basically, the decoder layer demuxes and decodes the segment and passes each frame to the renderer so it can be rendered on the screen. It also provides a native media buffer that the streaming engine actually interacts with, so it can be so it knows how full the buffer is and can flush out the buffer if necessary, et cetera. So the two very much interact. On this layer, we also have everything that's all of the DRM part. And as DRMs are designed, obviously, to protect content from theft, the DRM code and the way they work are completely hidden from the users and from the developers. So your decrypted data is actually never going to leave the decoder layer, so it's not going to be able to be intercepted. So today there's been some effort to standardize DRMs in HTML5 through common encryption and through encrypted media extensions. And so that has allowed broadcasters now to basically encrypt once per container or codec and then use several DRM systems depending on your different browser. Do you have any questions about that before we move on to what you should be looking for? No? Okay. Okay, so what are you looking for if you're actually trying to develop or buy a video player? So flexibility is one of the biggest beauties of HTML5 and one of the biggest advantages also of using open source. But you really need to consider what exactly do you want to customize. That's going to depend a lot on your use case, a lot on your feature requirements and your business goals, and also your current workflow. So that's probably the biggest thing to keep in mind. Bear in mind that the amount of development effort that you're going to be able to put into your video player very much depends on the resources that you have to allocate to it, and also your ability to maintain something in production, which is often not an easy task. So let's dive into the features that you need to look for and check when you're looking for different options on video players. First is kind of general criteria, device, format, and codec dependencies, I like to call it. So obviously, you want to know, this sounds very simple, but the first thing you might want to do is actually check that your streams play with the media engine that you've chosen. Because with all of the different ways to decode, to encode, it's not like 100% given that your streams are actually going to work well with the engine that you've chosen. So that's something just to kind of do right off the bat. Then once you've verified any like basic playback criteria, you'll probably want to look at some of the UI and business features that you absolutely must have. So we talked about them in the first part of the presentation. It can be DRMs, DVR, subtitles, whatever you're looking to absolutely have. The different media engines out there cover a broad range of features depending on their focus. And so you can very easily see what one can do as opposed to another. You can obviously also add these features yourself if you have the time and the resources to do it. And in that case, you should definitely check if your media engine is easily extensible. The rarer the feature, the more likely it is that you'll have to actually build it yourself. So you want to see if you have a framework that allows you to actually do that. The third category of criteria that we would want to stress is more pertaining to your actual media engine. So beyond the most basic features, you definitely want to look at the performances offered by the different solutions. And some of the most important performance criteria that we've identified are the following ones that you can see on the screen. The startup time, which is the time that the player takes to load the first video frame. Obviously, if you're doing a live or low latency use case, this can be extremely important. And so it's important to assess that, what kind of mechanisms are being used by the media engine to actually get that first frame. They handle it all differently. And so you might have one media engine that's actually much more adapted to your use case than another. The second one is just your ABR algorithms in general, because they're so crucial for the user experience. A good ABR algorithm is going to try to both optimize your average or maximize your average bit rate and minimize rebuffering. Some of them, they all do it differently. And some of them are better with the maximization, and some of them are better with stopping rebuffering. So again, just know what you're looking for in terms of your use case, to know what's important to you so you can actually make an informed decision about what kind of media engine is going to be right for you. And then finally, error strategies are a little bit less obvious at first sight. But a good media engine is not going to stop because it fails to obtain a segment. So especially in live streaming, if you have a live streaming use case, you should definitely have a smart retry and error strategy in order to handle any sort of network instabilities. Then fourth, we just generally, if you are tempted to venture away from the tried and true solutions, you're going to want to know that your media engine is going to hold up and that your video player is going to hold up. So just look at your GitHub metrics on that one. You don't even necessarily need to know how to code to see that a media engine is well maintained, if it has people working on behind it, if it is used by a large community, how fast are pull requests being being integrated, et cetera, et cetera. Just know that it's well maintained and you're not going to have a problem later down the road because of something, of feature support or anything else. If you actually, well, I mean, if you have a common use case and you're not trying to do a lot of development effort, that last slide is probably the basic things that you want to look for, and you probably won't have to go any further. If you do want to do a little bit more development work on it, you'll probably want to also check some of the things that we've listed here. Make sure that the Media Engine API is simple and understandable and stable. Make sure it provides everything that you need in order to incorporate any of the features that you're looking to incorporate. There are some media engines that have very easy extensibility features, like the possibility to replace the ABR logic or the ABR rules, some of which are a bit more difficult. So definitely check which parameters are customizable and make sure those are the ones that you need. And also, going along with that, it's also important for the API to expose certain playback and traffic events in the case that you actually want to build your own QoS metrics or kind of use a third-party plugin. Also, you obviously want to see that it has good debugging tools that are simple and easy to use, just to make life easier for you when you're doing when you're developing. If you're going to do more intense development on the player, there are several additional things to take into account. A good media engine needs to have both a robust core design and allow external developers to add features easily. And that's a difficult balance to strike. It's important not to kind of over-complexify a media engine by making everything changeable. So make sure the parts that you want to change are changeable, and yet that the media engine architecture is kind of simple and understandable to you. You also probably want to check the build system so you can make sure that you can easily integrate it into your workflow, especially if you're treating the media engine as a dependency. And then look at the testing, the unit tests, and the coverage, how much code is actually really covered by the testing. Media engines are pretty complex software, so the chance of introducing any regression bugs is pretty high, especially if you're dealing with a lot of new features. So do check out what's actually covered by the unit tests. And then finally, just as I mentioned, community and support. One of the most important things to see is that it's well maintained, that people are responsive and working on that to make that very easily usable by the community. So let's take a look at what's out there. Once you have all of those things in mind and have an idea of what you want to do and what you need to do, you can start looking at your options. We're going to present 4 different open source media engines today. Disclaimer, these are some of the best options actually out there. They're the ones that have gained the most traction. So keep in mind that they're all good options, and if we're going to say a couple pros and cons, but there's nothing really make it or break it about any of these media engines. They're all very good choices. And so we just want to give you a reference point and kind of point out some of the differences to make you aware that it might be important for your use case.
Yeah. So the first one, the first media engine we're going to talk about is Dash.js. So Dash.js is probably the most popular Dash HTML5 player out there. It has been created by the Dash Industry Forum, which is a huge consortium of big and small companies promoting the Dash format. Actually, it has so many members that your company might be part of it without you even knowing it. And this brings it a lot of advantages. So first, it's led and maintained by Akamai, with a full-time person working on it. You can also easily ask questions and support on the GitHub, Slack, and their mailing lists, with a very quick response time from the maintainers and the community. It has a big community of contributors, composed of a lot of tier 1 broadcasters like the BBC, and also a lot of people using it today in production, so it has proven itself for usage at scale and at production. And finally, as it was the reference player to showcase the features the Dash format can provide, it also supports a very impressive number of different features, like multi-audio, all kinds of subtitles or captions, etc. On the cons side, the fact that it's a project led by a big consortium made it quite complex and sometimes slower to move forward. So because of his history as a proof of concept player, Dash.js has a quite complex architecture, which makes it less easy to get in for a newcomer, even if that's changed a little since they released the V2 recently, like a few months ago. Also, it only supports the Dash H.264 subspec of the Dash standard, so it doesn't support like the VP8, VP9 codecs and WebM. So the second media engine is Shaka Player, so it's also a Dash media engine. So this is a JavaScript player built by a team at Google. So as you can expect from Google, it has a robust and well-thought architecture with good test and best practice processes and performances. It's also the only one out there that can play WebM, VP8, and VP9 codecs. And like Dash.js, it also has a very good support on GitHub and the Google groups. On the other side, well, you can expect some of the cons that come along of a project built by Google. So first, it's very Google and Chrome centric. So the developers build it for a certain purpose and are less inclined to work on the use cases that don't benefit them directly. So there are less supported features and less tests on other browsers, basically. Also, the core team has a strong lead on the direction this player should take, so they are more strict on the new additions and give less extensibility options to the users, to the developers. And finally, it uses Google dev tools like the Google Closure Compiler that are today a little less popular and known than the classic NPM ground Webpack stack. So that makes it a little less used and known, but it's also used already in production by several very big tier 1 broadcasters in the US and in Europe, so it's also a very good choice. So then let's talk about the HLS media engines. So the first one is hls.js. So this project has been developed by Mongi from Dailymotion, who is also the creator of Flash.ls, which is the framework used today by most probably more than 90% of the players that want to play HLS in Flash. So hls.js is a sort of a second version of Flash.ls. In JavaScript. So it benefits from all the huge experience of the former and has led to a very elegant yet simple architecture and API for HLS.js. It has a huge traction, and even if it's only 1 year old, and today is the de facto HLS media engine for HTML5. It also has a great support and community, and you can very easily reach out to the contributors and maintainers on GitHub and Slack. So there are not a lot of cons I can think of for this media engine, but if we really need some, I would say that first you have to keep in mind that it's still a quite young project, so 1 year old. So it doesn't support all the HLS features today, even if it's supporting more and more with the time passing. And second, as in JavaScript, you need to do transmuxing for HLS to be played. It doesn't support DRMs like WideWine or PlayReady, but that's the case for any HLS player in HTML5 today, even if that also could change with the new CMAF standard pushed by Apple and Microsoft. And so the last one is Gs Contrib Hls. So this is actually a plugin of video.js developed by the Brightcroft team. So the biggest advantage of this plugin is that it has a completely seamless fallback to a Flash media engine. So basically you can play any HLS stream also on older browsers with it. And also it's quite integrated with Video.js, so it makes it very easy to use and install if you are already using Video.js. But this is also, of course, a minus because you can't use this media engine as a standalone media engine, and you're tightly linked to Video.js. So this can be a no-go if you want to have your own UI and business logic framework. That said, there are a lot of off-the-shelf player available as well, with a lot of features and options to choose from. The logic here stays the same. If you know what you're looking for in terms of business logic, UI, playback features, as well as formats and performance, you will be able to assess the pros and the cons to make a good decision on what solution is right for you, be it open source or commercial one. And actually, a lot of these off-the-shelf players use media engine we just talked about before. So, for example, GW player uses Shaka for the dash playback. Brightcroft, of course, uses Video.js, and like Kaltura uses Dash.js, etc., etc.
So yeah, just to finish up, there are obviously a lot of questions that you need to ask yourself when you're deciding on an HTML5 player and whether you want to actually buy it or build one yourself. The choice is obviously a trade-off. Building yourself requires the talent and the ability to maintain the player, to customize and then maintain the player in production. And it's important to obviously find that the right trade-off between using your internal resources and versus the cost to actually buy and customize. Be aware also that the player itself is not the only thing that you're going to need to consider when you're making the transition from Flash to HTML5, if you're doing that today. There are a lot of considerations with encoding, with the addition of DRM, switching over your DRM workflow, switching over your ad workflow, doing HTTPS in HTML5 that are actually going to probably add a significant amount of time to your development roadmap. So do have that in mind when you're choosing a player, that it's not just the player, but everything that goes around it as well, if you're making that transition. And as we've stressed from the beginning, the most important thing that you need to know is your use case and how complex it is, as well as knowing what you have in terms of internal development resources and your go-to-market timeline. So that's basically what you need to take into account to make the choice. Do you have any questions? Okay, so how do the 4 media engines that we compared handle the startup time of the rendering of the first frame? Do you want to take that one?
Yeah, most of them have a strategy of getting the lowest quality first. So that's also that's one of the biggest factors to get the startup time, the smallest startup time possible. Because in terms of loading the player itself, it's we did a benchmark actually for the 4 of them. It's between 50 milliseconds and 100 milliseconds. So the biggest thing you want to optimize is basically your first segment to make it the smallest possible with a lower quality.
It's not always by default the lowest quality, but that's one thing that's customizable in each of these media engines. Actually, you can change that rule.
HLS.js uses the first quality that is listed in the playlist in HLS, which is often the median one and not the lowest one. So that's something you can change by tweaking the options of the engine.
Do one of them stand out as performing better in that aspect?
For startup time?
Yeah.
Not that much. As I was saying, to get the player ready, they're all between 50 milliseconds and 100. So then the rest depends on your stream more than on the player.
Yeah.
So with Video.js right now, we're using the Hls Contrib plugin.
Yep.
Mm-hmm.
And one of the things that we like about it is that it's very extensible in that way.
Mm-hmm.
And we trust that if there's ever a problem we need to use some website word, or like if we had to, we could theoretically do it.
Mm-hmm.
Are the other frameworks similarly extensible, or does it vary between them? Is there another one that?
You mean like as extensible as Video.js?
Yeah.
Not that many of them. I think that's probably the only one that has that's open source, free, and has so many plugins and like extensibility options. You have like all the GW players and Flow players, but it's commercial solutions, so it's a lot more difficult to like customize and extend.
And so the HLS.js, which I have heard of,
Mm.
is that I'm assuming that supports other video formats as well, but it's just called the HLS.js, or is it literally just?
No, it's just HLS in GS.
Mm-hmm.
Yeah. No, they don't plan to support any other formats. But like we built at Streamroot a provider for HLS.js for Video.js, so you can plug the HLS.js media engine into a Video.js if you want for that. It should be on our GitHub.
Any other questions? Okay. Thank you very much.
Thank you.